So today's material is going to seem a lot like yesterday's at times, but we're dealing with some linear functions again. Okay? Tell your neighbor what linear means.
Straight line.
All right. You're good. Logan, what do you got? What's linear? It means a line. Okay, in a picture, it's a line. What does it mean in a table? Aaron, what's it mean in table? Straight line. How about a table? Like, kind of making it a little more tough. Sarah, you know, obviously, your hand's up. Oh, I don't want your hand up yet. Okay. Well, how many of you think you know what's in a table? What it means in a table? Okay, a couple of you. So we're going to explore that a bit today. I will tell you that one of these down here is going to be linear. One is not going to be linear. Okay? You're going to work with this, your partner, complete this, each table, the similar figures. Okay? You need to find the perimeter. You're going to find the perimeter and the area. So when it says complete each table for a sequence of similar figures, they're just saying, hey, what happens when we change the values of x? These figures change sizes, therefore you're going to have a bunch of different similar figures. Okay? They're telling you what x equals here. In order to find the perimeter, you have to know how to find perimeter of a rectangle. In order to find the area, you must remember how to find the area of a rectangle. So quick reminder, what's the formula for perimeter of a rectangle? Write it down on your paper. And what's the formula for area of a rectangle? Write it down there. All right, Lexi, what do you got for perimeter? 6, so you actually did some math there. Okay, so how did you find the perimeter? Good, so you said 2x times 2 plus 2 times x. All right, so where did you get the 2x plus or times 2? Okay, so you get 2x. Where's the other 2x? Okay, you got that one up there as well. Okay, and then you have this x over here. So that's one way to write it. Or you could just say 2x plus 2x plus x. Perimeter's distance around. Okay, x, back there, that x. How do you find area? The length times the height, or length times width, or base times height. Any of those would work. Okay. In this case, what is our length? 2x. This would be our length, or this. It doesn't matter really, right? So we'll call this one our length. Usually we call the longer side our length or our base. So we'd say 2x. And our height is? Our height is x. Okay? All right. Go ahead and find your areas. Graph your points. You guys are done. Let's go ahead and get those filled in up here, please. You guys come up and put the answers. Fill in your solution. Dude, no one has any of the answers.
Oh.
Fill them in, man.
I'm still graphing it.
Oh.
I think I screwed up. It doesn't look right.
And then if you look back, you can
Oh, this is like 5, 10, 15. That's weird. It'd be like down here. Wait, this is going like 5, 10, 15, 20.
Yeah.
How?
The
How?
graph. It's not going to go by.
All right.
Yeah.
How we doing? You plotting all the points?
Yeah.
Okay.
I'm trying to.
Okay. How many have your pictures done? Your graphs are done? Yeah, graph them up. After you're done, graph them up. Make sure you're doing it in pencil, then you can fix it if you need to.
I hope I did that right.
There's only one I know what it is, right?
Everything that's wrong.
Well, okay. They're wrong.
I always like to be critics. You can be like Cisco and Ebert, Cisco and like the movie people. You can be like the Muppets that sit up.
Oh
at
yeah,
the
the
top
critics
and,
of the Muppets.
look at everyone and make fun.
Yeah.
Sheesh.
And
All right.
Muppet Treasure Island, they're funny too.
Let's see. Letter A. 20 or 10, 20, 36, 40, and 40. All right. Well, hey, you guys, sometimes it's helpful if you simplify first. Okay, that becomes how many x's? That becomes 4 x's. And this becomes, well, we still got 2 x's. So it's a grand total of how many x's? 6. So it's a little easier if we just think of it as 6x. Now, why didn't I tell you that ahead of time? Well, I was just wondering how many of you would do that on your own. How many of you did that on your own? Okay, good. Okay, so if I say x is 1, well, 6 times 1 is 6. I think this might be 6. And if x is 2, 6 times 2 is? X is 3. And so, there we got it. So that means our grid here went a little awry.
Yeah.
Because our table was a little awry, and I don't even like rye. Okay? So we get 1, 6, 2, 12, 3, 18, 4, 24, 5, 30. Oops, 5, 30. See, I shouldn't have used my darn.
5:30.
This one isn't supposed to be. My bad.
All
All right. We put our cool line. Is this discrete or continuous?
Discrete.
Huh. Here's my question. We figure out if it's discrete or continuous. Remember, discrete means they're just points. Continuous means I would have things that exist in between. So the question you have to ask yourself is this. If I'm looking at the bottom numbers here, this bottom represents what? X. This represents, what is P?
Z.
Come on, what's P stand for?
Oh, perimeter.
Perimeter.
Oh.
My question is, could we ever have a value for X that is not a whole number?
Yes.
Is it okay to like have 1.5?
Yes.
Okay. Hey, stay with me. Is it okay to have 1.5? If I have 1.5, am I going to get this perimeter right here? Maybe. Let's see. If 1.5, what's 6 1.5s? 6 times 1.5. That's where you guys figure it out. I'm not even asking you to do it by hand. You have the calculator. Or you could just take 1/6 and then take half of it and add it together.
9.
It's 9. Is that about 9?
Yeah.
Yeah. So that means since since you can have the halves in there and still get actual values, this data is continuous. It goes on forever. Now, does it go on forever this way?
Maybe. Technically, but you can't have negative perimeter.
No.
Well, some of you are actually going to leave this class really knowing the math because you're challenging yourself to think. Some of you are just like, well, if I copy down what's up there, man, I got it done, and then I could feel good about it. Hey, stay with us and think through it. Can I go this way? Should I have an arrow down here?
Only in math can you go that way.
I should. Is that right? All right, well, let's see. Everyone's yelling yes. Why are you okay with having an arrow down there? Because it's continuous. I definitely believe it's continuous this way. What type of numbers are these over here?
Negative.
Negative. If I do put like -1 in here, what's this length?
It's a negative length.
Okay, now I really want you thinking about this. If those are negatives over here on the x-axis, and these are negatives over here, this x, if I put a -1 in for x,
Not only negative length, but negative
2 times -1 is what? -2. So the length of this side is -2. Everyone agree? Okay, so right now I should just say everyone owes me $50. Everyone agree?
No.
Okay, you guys are just like agreeing to anything. This length is -2.
absolute value.
Come on, use logic. What is wrong with that statement?
Can't have a negative length.
You can't have a negative length, man. Okay, oh, there's the no bugs. I was going to say no. Okay, you guys like yell. Kaib's back there like, yeah! Okay, you guys have to be yelling. No! Okay, that's not right. You can't have a negative length. Therefore, this is...
I figured it out.
Can I continue this way?
No.
No. That means you stop at 0.
I'm so proud of
But you
myself.
continue in this direction forever. Because those are positives. Am I positive? I am very positive. Okay.
Alright.
All right. This is continuous. Let's move on to area. Did anyone simplify first?
Yes.
No.
Yeah, area is 2x times x. What's another way of saying 2x times x?
3x.
Not 3x. That'd be 2x plus x. 2x times x.
Yay,
2x squared. X times x is x squared. Okay, Kai, you should have been yelling that one right. Like, x squared. Okay? X squared. Twice the power of u back there, x. Just saying. Hey, x squared. Inside joke, right?
Right.
Oh, you. All right.
If you've taken math, it's
Kai, did you explain it to him? All right. Hey, so you go 2x squared, you square it, you get 1 times 2 is 2. These are all right? Is this linear? Is it continuous?
Not linear, but yes, it's continuous.
Continuous. Will it keep going up forever?
Yeah.
Yeah, it should, because positive. Will it go this way?
No.
No, it starts there.
Can't have negative area.
Okay, you can have, we've already talked about having links that are halves here, so that's okay. This is continuous data. Is it linear? So it's continuous, not linear. Why is it not linear? Tell your neighbor.
It's exponential.
Curving.
It's an exponential.
It is exponential. It is not a straight line. It's
a
curving.
parabola.
Is this one linear? Yes, this is a straight line. Is it continuous? Yes, it's continuous.
If you were to continue the area onto the x
All right.
negatives, it'd be a parabola.
It would be. Yeah, right. Hey, okay. A couple of the guys up here actually figured out that this is quadratic or exponential. Well done. Okay. Move on, please. Why don't you take a look at your student journal?
Found it. Plus page 65.
Yep. Next page. What do we have? Yeah, page 65. What is that?
Linear functions
Yeah,
continue.
it's exponential or explorations.
It's titled Linear Functions Continue.
Linear functions continue. We're not going to do that page. We're just doing the first part here. Okay, so turn it again. Page 66. So that's the one I want. 66, linear equations in two variables, linear function, nonlinear function. A solution of a linear equation in two variables, discrete and continuous. I want you to define these terms as best you can right now, or as many as you can. If you don't know it, just skip it and move on to the next one. Based on what we've talked about, can you give an example of which one or what those solutions are there, or those definitions? Okay, linear equation in two variables. Anyone know what it is? Bet you learned it last year. Some of you learned it first period this year.
Maybe.
Two variables have y and have x. They're both on opposite sides. Now there are two other pieces.
Y equals mx plus b.
Y equals mx plus b. Linear equation. How many of you remember y equals mx plus b? Me, I remember that. Yeah.
Me remembers a lot.
Good. M, we'll talk about what they mean later, but this is a linear equation in two variables. Y equals mx plus b. Please note a few things. M is to the first power. That means we don't see a little number up here in the exponent. If you see like x squared, it's no longer linear. It has to be to the first power. And the way we show that is we just don't put any number up there. You won't see a 1. Linear function. Well, linear function would just be this. F of x equals mx plus b. What do you mean f of x? I mean f of x. It's function notation. It just replaces the y. Okay? It allows us to say, hey, I want to put an input in for x, and I throw it here saying, okay, this is the key to this equation, and then I solve. A nonlinear function. Nonlinear function means that x is an exponent, or x changes this form a bit. A nonlinear means it would form a graph that is not a straight line. We'll look at a lot of different things there. Thank you. We'll see a bunch of examples here. This is a good one to start with. Form a graph that is not a straight line. That's one example.
I figured out my graphing calculator at home.
Solution to a linear equation in two variables. A solution is just a coordinate. An xy coordinate.
Oh.
And you may expand on these as we go. What's discrete mean?
Not a continuous line, but it is going in a line.
Good. So if you sometimes a good picture is just that's discrete data versus continuous data. Continuous has a line or a curve of some sort. It has points that are connected in some way. Maybe it goes like this. Does it have to be linear? No. It doesn't have to be. It's just connected. It means all of the values in between the halves and the quarters, all of those things for x will work. Here, these are just usually whole number values that work. Okay? So those are really quick definitions. And you're going to add to these as you go, I'm sure. But what I want to do is make sure that we're very, very clear. This is going to seem extremely redundant, but let's see. You guys go quickly. Quick review. Linear or nonlinear?
None.
Linear or nonlinear?
Linear.
Continuous or discrete?
Continuous.
Continuous or discrete?
Continuous.
Okay. Very good. Straight line is continuous. And connected points are continuous. Okay? This one is linear because it's straight line. This one is nonlinear because it's not a straight line.
You said straight line is continuous, but
and it's also,
but a straight line can also be a discrete thing. Because the dots could be in a line.
You're right. We haven't got to that yet. Okay. Linear or nonlinear?
Linear.
Linear or nonlinear?
Nonlinear.
Aren't they straight lines?
Yes, but they're not linear.
Good. They're going in different directions. So even though they're straight, they change direction. Okay? The change of directions, the evil twin of one direction. Okay? There we go. This is nonlinear. Continuous or discrete? Continuous or discrete? Oh, man, you guys are all over it. Okay, well, let's see if you got this then. Linear, nonlinear. Talk with your groupies. Okay, so everyone says A is linear. All right.
Except for two people.
You didn't? You said it's nonlinear. You're not sure?
I don't think it's linear.
Okay. Can someone that thinks it's linear tell me why they think it's linear? Isabella, why? There's a pattern. So what's my pattern? So it's going up by 3. Good. All right. What's the other pattern? Logan? Going down by 6. That means it's? Linear. Now, just because a good reason is not it has a pattern. It has a constant rate of change. Okay, because we can have a pattern and it could be nonlinear. Okay, but the rate of change is constant. Now, we're going to talk about what the rate of change is, but right now, what that could mean to you is the x's are increasing the same and the y's are increasing the same. When I say they're increasing, they're actually increasing by -6. That's how we'd say that. So as x increases by a constant, y increases by a constant. Okay? Is x increasing by a constant here?
Yeah.
Yeah, by 2. So we're good there. Is it increasing by a constant for y? Plus what? Is that a pattern?
Yeah. But it's not
Yeah.
constant.
I mean, this is like that went up by 4 and that went up by 4. This is actually called quadratic because my second level is constant. This is quadratic. Okay? So there's a pattern here, so that's why we can't just say, yeah, it's linear because it's a pattern. This is nonlinear, even though there is a pattern. It's just not a constant rate of change. Then the first set would be, yeah, if it's the second level, it's not a constant rate of change. Yep. All right. How many think they got it? How many think they can describe it? Oh, well, we'll see if we can describe it on the next ones here. Here, we've got it. Next 2. Give them a shot. Make sure you say yay or nay and why or why not.
Yeah.
All right, here we go. You need something? Okay, linear, nonlinear. Linear plus 1 all the way down, right? And then plus 2. Okay, linear because constant rate of change. All right. Linear, nonlinear? Nonlinear. Now, it was pointed out to me, and these are good things to point out. When you're seeing if it's a constant rate of change, it has to be addition or subtraction. Okay, so as Julian asked, she said, like, I mean, you're actually multiplying by 1/2 every time. Okay? You're cutting it in half. You're dividing by 2 every time. So it has to be a constant addition. So when I say this, I'm looking at this, and I'm actually adding -8. Or subtracting 8 if you want to think of it that way. Adding -4, and then adding -2.
That 2 would be a parabola, wouldn't it?
Okay, that would be a parabola.
It's just one word to say.
Oh, hold on. No, 4 and 2. No, it wouldn't be a parabola. It's exponential here. It's actually exponential.
Parabola is fun to say.
So this is non because not a constant rate of change. All right. Go back to your notes. And make any notes about linear and nonlinear using tables. You know what it looks like in a graph. Now, explain to yourself what it looks like in a table. Maybe even give yourself some examples if you go back to your note page. What page was that again?
66.
Last piece for today. Let's see if you guys got it. Linear, nonlinear. We're now on equations. So we've looked at graphs, we've looked at tables, and here are equations. Now let's see if we can figure it out using an equation. All right. Yeah. It could be. Oh.
Yep.
Let's see. Number 5, linear, nonlinear. Who says linear? Who says nonlinear? Okay, this one is linear.
Linear.
It's linear because it's in the form of y equals mx plus b. Now, some of you will go, hold on, there's no number in front of the x. You're right. When we don't see a number, it is?
1.
It is 1. It is linear. Still linear. Yep, it just starts at 9. Okay, how about actually, let's go to the easy one. Number 7, linear or nonlinear?
Non.
You sure?
I'm sure.
Okay, Tyler, why is this nonlinear? Yeah, because it has like x to the power of whatever it is. I can't see it. It's squared. Okay? Yes, it is nonlinear because of the little power up there. X squared. That's our issue. Okay? Number 6. It's a little tougher. How many say linear? How many say nonlinear? How many have no idea? Okay, so first thing to ask yourself is x to the first power. X is to the first power. Now, anytime you have an x on top, you can actually rewrite this as y equals 3/5, and you can just put the x right there. So now if I give you that, is that linear?
Yeah.
Yeah, some of you go, well, there's nothing back here. Well, that just means you're adding 0. That is linear.
Don't take that away from me.
It's in y equals mx plus b. Now, let me caution you, if x was on the bottom, that would be nonlinear. So if x is down below, that's nonlinear. So I'm going to add a piece here. If this was, like if we call it, let's call this one number 8. Okay? If we had y equals 3 over 5x, that is nonlinear. Because the x is in the denominator. The x can't be in the denominator. It's not in the form of y equals mx plus b. You have y equals, we call it c over x, or a over x. Okay? It's in, the x is down below. So, now in your notes, make a note to yourself. Equation-wise, how do you know if something's linear or nonlinear? Write it down, please. Your assignment today. Total yay. Your assignment. Everyone take a look at page 68, please.
Ooh, we did page 68. Yay.
Okay, on page 68, that is... No, that's not your homework. That is... Oh, yeah. Well, I guess it is your homework because you won't finish it in class today. Okay, so page 68 of your student journal. Go ahead and work on that. Most of you can finish and you can get a chunk of it done. You have 5 minutes. Logan will be done with most of it by then. Okay? Hold on, he's walking around.